Hello and welcome back to another video in the 8th lecture of ComSoc 375 at the University of Maine at Augusta, undergraduate social networks. Now, over the last couple of weeks, we've really progressed in the way we've been thinking about and talking about one-mode and two-mode networks. We started out with just an abstract idea about what two-mode networks are. Then last week I presented you some data regarding just a few members of the House of Representatives, the United States House of Representatives, and I asked you to try to generate some one-mode network data from the two-mode data. In the lecture that you'll find associated with week 8, that's not this video but the prior video, we'll talk about some of the tricks and difficulties in working with that data. Most importantly, taking apart the different kinds of two-mode data and separating them when importing them into UCINet for use. The next step is to move beyond just a subset of information for a few actors in a network and to look at an entire network. This is a problem of boundary specification, which you can review by taking a look at the glossary. But to hum a few bars, the problem of boundary specification is one of deciding who belongs in the network and who doesn't belong in a network. What ties belong in a network and what ties don't belong in a network. It's an important question because if we're not careful, a social network can quickly get very large. I'm going to show you some actual social network two-mode data from a real political object that should be relevant to you, namely the 125th Maine State Legislature, which just completed its work for the years 2011 and 2012. As I speak, a number of these members are running for re-election in the 2012 elections. Let's take a look here at a Microsoft Excel file. It contains a number of columns. Each column describes a different variable, which is something that you can measure that varies. It can be someone's first name, their middle name, their last name, a suffix, senior or junior, their title, their party, their gender, what district they represent, what city they represent, a list of committees that they're on. And now we could have a text list. For instance, we know John L. Martin, representative for the 1st District out of Eagle Lake, is on the Appropriations and Financial Affairs Committee and also on the Joint Select Committee on Joint Rules. But if we want to express that as a quantitative variable, what we do is we list all the possible committees, and you can see them listed in shorthand here. ComAgra refers to the Agriculture Committee, ComApp refers to Appropriations, and so on and so forth. And you can see a 1 for John Martin under ComApp, and a 1 on JCom Roll. What do those mean? Well, we can go back to the text list, Appropriations and Financial Affairs, and the Joint Select Committee on Joint Rules. A 1 indicates that a person is a member. A 0 indicates that they are not a member. I further went in and I collected information on each district. The percent urban in a district, sometimes that's 0 for a rural district. The percent non-white population, this is something that varies. It never gets very high in Maine, but it does vary. You'll see here for, who's that? A representative out of Old Town, James Dill, the percent non-white goes up to 9.6%. The percent female also varies. The median age, is it an old district or a young district? Whether there's a college dorm in the district, whether there's military quarters in the district, and the percent of same-sex partners in the district. Finally, I've gone back to the Maine Legislature website, okay, at mainelegislature.org, and I've gotten information on co-sponsorship of a number of bills. They're called LDs for legislative documents in the state of Maine, but these bills, which are proposed laws, this set, LD 8, 37, 257, and so forth, all the way up to 1731, have to do with sex offenders. Then there's a second set that has to do with domestic violence, a set of 5 bills from LD 708 up to LD 1576. I've collected that information for a lot of politicians, every politician in the state of Maine who is in the Maine State Legislature. And that sums us up to, I have to widen this column just to get the numbers out. If I give each of them a number, we find we have 189 members. That's quite a few. Okay, so this is complete data now. I've specified my boundary. My boundary is those who are in the Maine State Legislature, either as representatives in the Maine House or as senators in the Maine State Senate. Both senators and representatives, those in the Senate and the House in the state of Maine, can co-sponsor any of these bills because the two houses work together in a way that is not the same as the U.S. House and the U.S. Senate do. Now this is clearly two-mode data. We're not comparing yet members of the legislature and their relations to other members of the legislature. We'll get there. What we have now are in rows, individuals, and in columns, affiliations of the individuals. That's the first kind of two-mode data that we have here. We have committee assignments. We have other kinds of two-mode data as well. We have party affiliation. We have district affiliation. Now, in this sense, we're never going to have an overlap because there's only one representative for each Senate district and one representative for each House district. We have two-mode data regarding gender. Now that's interesting because there is a property in social networks called homophily, which is that individuals who are similar to one another by age, by gender, by education, by religion, by income, tend to be more likely to form ties with one another than people who are different along those lines. It's an empirical regularity. Will we find it here? Will we find it here for another kind of two-mode data? Namely, the two-mode data of people, legislators, and political actions, which are the signing on in support of a bill. That is not a vote. It's an act called co-sponsorship. And for instance, we can see over here a 1 for LD 257. We can see over here a 1 for LD 1365. Another 1 over here, a 1 for LD 1576. What are these ones? Well, they indicate the act of co-sponsorship by people in those particular rows. So our co-sponsor of LD 257 is, if we move all the way over to the right, someone named Jeffrey Allen Gifford, who is a representative in Lincoln Center. We can find that that co-sponsor of LD 1365 in row number 19 is out of Bangor, and that is Sarah Stevens. There's more than one co-sponsor for many of these bills, and that means that we can think about a co-sponsorship overlap. Do two members of the legislature both co-sponsor a particular bill? If they do, they have an overlap of 1. Do they both co-sponsor 2 bills? Well, they have an overlap of 2. That's a tie strength. And if we believe Ronald Breiger and Scott Feld, that foci, that is, joint activities or group memberships or shared actions, tend to focus ties, then we can call the act of co-sponsoring together perhaps the result of some foci. What might those foci be? Well, one focus might be shared committee membership. If you spend time with someone on a committee, you regularly meet, you regularly work with them, might you be inclined to form a tie? And might that tie lead you to some shared understanding of how politics works? It's possible. Might membership in the same party be thought of as a focus? Could it be something that leads to shared party cohesion, to use a term that Prell uses in her chapter on subgroups? Is a party a marker of cohesion, of belonging together, sticking together, creating party loyalty? It could be. What about gender? Well, if we believe in homophily, which is that ties form between people of the same traits, then we might expect men in the legislature to form ties with one another disproportionately, and females in the legislature to form ties with one another disproportionately. This is precisely the subject, by the way, of a paper that I've recently had published in the New England Journal of Political Science. It's about gender in the Maine State Legislature. And this is some of the data that I used to generate that data to run an analysis using a technique you'll use at the end of the semester, and creating a research publication from it. I've begun to speak, you might notice, in terms of hypotheses, suggestions about how one kind of similarity or one kind of association formed through some kind of network data might be related to another. How do we go about testing this? How do we go about assembling the data for this? Well, we do it the same way we did for just a few legislators. We just do it with more rows when we have the complete legislature. So what I'm going to do now is begin to create a set of matrices. They will begin as two-mode matrices, and they will end as one-mode matrices. I'm going to constantly switch over to the UCINet spreadsheet editor, and I'm going to start by pasting in, and then I'm going to head back, and I'm going to select an entire column, let's say, on gender. But you notice I have letters here, M's and F's. That's easy to remember, but it's not so easy for UCINet to work with. UCINet likes to work with numbers. So I'm going to assign each category a different number, and that's somewhat arbitrary. I'm going to say for gender, let's make F's equal to 1. I used Control H to bring up the Find and Replace menu. 55 of those. Interesting to know. Also interesting to know is how many M's we're going to have that I'm going to replace with zeros. Also using Control H for Find and Replace. Having selected just that column. 134. Now I have a set of gender data that I can work with. I am going to add another column. Oh, it didn't seem to want to add. But there it is. This will happen from time to time. I should check now to make sure that Fitzpatrick, Turner, Stevens, and Kane are indeed female to make sure it worked well. Let's check here in the data. I find Fitzpatrick is female. Joyce Fitzpatrick. Turner, Beth Turner, female. Sarah Stevens, female. Emily Kane, female. It looks like my data copied over well. Always check your work. So now I'm going to create MLeg gender 2 mode, a description of the 2 mode matrix that I have, which is why I put 2 mode at the end. It's about gender, which is in the middle, and MLeg standing for Maine Legislature, so I can figure out what I was doing if I look at this file again. I'm going to save it. Then I'm going to exit, and I'm going to head over to Data, Attribute to Matrix. And I want exact matches in MLeg gender 2 mode in the value for the column that is gender. Okay. In order to get this to work, it was important that I had column labels as well as row labels, because UCINet asks me to work with those, and that's great. So now I'm going to make the outcome be MLeg gender 1 mode, and it's exact matches. I think that's what I want. What did I end up with? I ended up with something really interesting when it comes to the text up here. I am hoping that that is just a text problem of fitting it all in. It looks odd, but if I look down, I see zeros and ones. When you get this kind of result in a log file, it is never going to hurt to data display a particular MLeg gender 1 mode. The actual, yeah, that looks a little bit better. Either to display it there, and it looks like I have sensible data, or to go back to the spreadsheet. And MLeg gender 1 mode data. Oh, yes. It was just a text wrapping issue. Look what I have here. I have 189 rows, 189 columns, and I have some sense here. How do I know it makes sense? Because I'm looking at Fitzpatrick, and I notice that Fitzpatrick is not listed as being the same gender as Martin. The row, Ayotte, Edgecombe, Willett, Clark, another Willett, or Long, but is the same gender as both Fitzpatrick herself, Turner, Stevens, and Kane. So this is a same gender matrix. I know also that these men here are all listed as being the same gender as one another, but not being the same gender as Fitzpatrick. Checking the data, I see that I have good 1 mode data that came from the 2 mode original. Let's head back and let's pick another example. Okay, I could do the same thing for party. It would be very similar. Let's make Democrats be equal to 0. Again, this is somewhat arbitrary. Doing a find and replace, having selected this column only, Control H. Let's replace D's with zeros. 88 of those. Let's replace R's with 1s. 99 of those. It's a Republican-controlled legislature. Now it turned this into Party, P-A-R-T-Y, or P-A-1-T. I'm going to fix that. Oh, what do I have down here? I have a U for unenrolled. We do have some unenrolled individuals. We're going to call those people 2s. Always good to go down and check. Now, do we have any other strange letters? Yes, we have an I. And we're going to just go through manually and replace that with a 3. This is Madonna Saktoma, who is a representative of one of the Indian nations. Excellent. And she's described herself as independent. So now we're going to take that party list and we are going to put that here. Let's go back out further. I notice I put it in twice now. That's fine because in the first column I'm going to copy and paste over that with my familiar old labels for names. For some reason, the spreadsheet is doing something odd. It seems to want to continually collapse to just one column. So by heading over here and writing in again, no, I want an additional column, I seem to be able to make the second one appear. I'm going to check, are Martin and Thiero, are they both Democrats? Are the next two both Republicans? Yes. So I seem to have transferred the data well. I'm going to save this now as mleg party to mode. I'm going to close the spreadsheet editor and head again from attribute to matrix. I'm going to reload this matrix now, mleg party to mode. It says, do you want the column for party? Yes, I do. And I'm going to rename the output matrix, just because that's how I like to do it, mleg party 1 mode. I want to use exact matches. That's fine. And again, the top looks funny because of the long names. But if I look in the data spreadsheet, mleg party 1 mode, hey, I've got something here. I'm going to go through a couple of more examples. You may fast forward if you find this to be a little humdrum, but if you're wanting to get comfortable with this process, please continue to watch as I do this. I'm going to move over, and there are a number of things that we could look at, but wow, you know what I'm going to do? I'm going to work through the committees now. And I'm going to take all of these individuals here. We're going to put in information on the last name, which is again our consistent label, and then over back to our Excel spreadsheet, and I am going to head over and I'm going to get all of the information and select it all the way over to the rightmost committee with a whole bunches of zeros and ones. I'm going to copy that and I am going to put in, I'm 25 more columns. I don't think I need that many, but I'm going to use them all. And then I'm going to paste that in. And I'm going to make sure that going over to the right that it includes the last one, which was COMGOV. It certainly does. Oh, it automatically truncated it to 19. Good. Now I'm going to save this. I'm going to check my data. I'm going to make sure it worked out well. Is Martin in ComApp? And is Clark in ComApp? Martin is in ComApp and Clark is in ComApp. Both of them. I've transferred my data correctly. It's very important. I'm going to save that as mleg committee to mode. Now, I'm going to do a little something different with this. We're going to play with this. I'm going to show you the two possibilities we could have here. Because these are affiliations, right? It's a particular kind of two-mode data. The second mode is a group with which one might be affiliated. So, I'm going to use data affiliations, 2-mode to 1-mode for this. And I am going to search for mleg committee 2-mode. Now, the first time I'm going to use row. What does row mean? You ever want to find out? Always look at that help button, click the question mark. And let's find row. Continue to go down. parameters. These are the options, in other words. Row by row matrix of overlaps. Row by row. What are our rows? Legislators. Legislator by legislator. Yep, that's what I want. So I'm going to create that. I'm going to call it mleg committee one mode. And I'm going to hit OK. Now I have a lot of stuff to look at here, but let's call it back up again in our spreadsheet, mleg committee one mode. That looks like it makes sense. Are Martin and Clark listed as sharing the committee? Yes, they are. That's the Appropriations and Financial Committee. Excellent. We know Martin, in his diagonal, we know he had two committees. He shares two committees with himself. This makes sense. It looks like it's done what we asked it to do. The data has a clarity to it. It looks like Martin and Ayotte did not share any committees. Okay, we could go back and we could check that. That's great. I'm going to show you another trick. Because remember from the lecture that you've just been reading that we can create two kinds of one-mode data. We can also talk about the connections between committees. And the connections between committees are the number of shared members. Now, there are a lot of members who only have one committee assignment. So it'll be interesting to see, and I don't know off the top of my head how this will turn out, how many ties we actually have between committees. But I'm going to do that by going to Data, Affiliations, 2-mode to 1-mode, and I'm going to start with the same 2-mode committee. I'm always in UCINet. It helps to reselect the matrix just to be sure you're getting the right one. I know it's a little picky of me. And I'm going to pick column this time. Why? If I look in help, what does column do? It represents a column by column matrix of overlap, committee by committee. Wow, so this is going to be member overlap between the committees. It's going to show us a network of how committees are tied. That's cool. Because networks aren't always just between people. And I'm going to call this something special. I'm going to call it mleg committee experiment. Something a little different so that I don't confuse what I've done from one round to the next. I'm going to hit OK. Oh, and now this is easy to look at right away. First of all, we can see in the diagonal that there's a large set of numbers. And they tell us how many people are sitting on each committee. Wow, the Appropriations and Financial Committee is big. The Committee on Crime is big. The Committee on Energy is small, as is the Agriculture Committee. Excellent. Okay, so I'm going to exit now. That is a set of ties indicating which committees are strongly tied to the other committees. If you went back a couple of seconds, you could see that there were some connections between committees. They typically were small numbers of overlaps, but the overlaps did occur. Now finally, I'm going to go and I'm going to collect the variable I'm really interested in, which is 2-mode data. I want a matrix that describes actions taken by these legislators. Because, you know, politics is about action. It's about what you do. Not just sitting in committee, not just being part of a party. It's what bills you support, what bills you sign on to as an official listed supporter. That's co-sponsorship. So, heck, let's head back over to our spreadsheet. And let's get that last name again. And then back over here, we're going to paste that in, and then we're going to head back over all the way up to the top. Now let's collect some information on bills about sex offenders. Whoops. Okay, always make sure. I want to only pick through column AX. Always be sure what you're doing. Always be exact. Okay. Now here we have some interesting information, which is that Cynthia Dill doesn't have any information for her. Okay, but we have some missing data. That is somewhat troubling. Then she could not be a co-sponsor there. So I'm going to enter that as zeros. And I'm going to select that data again. Always be sure to think about those issues so you know that what you're doing means something meaningful. Okay, I'm going to collect that information over here, and I'm going to go back over. I know that was fewer than 20 columns, but I'm going to add in, heck, 25 just to be sure, and then I'm going to paste these in place. Okay, now Gifford, I'm going to check my data, is a co-sponsor of 257. What else do I want to find? I want to find another co-sponsor. I want to find that Cray was also a co-sponsor of 257. Is this true? Let's check. Gifford and Cray, and then a bunch of people across the bottom. Okay, Burns co-sponsored the 257 and then two others. Is that so? Burns, 257, and then two surrounding. Good. Solid data. I'm going to call this MLeg sex off for sex offender legislation to mode. I'm saving it. I'm going to exit. And this is like an affiliation in that someone is affiliated with an action. And we want to see who overlaps in their co-sponsorship. So we're going to head to display. No, excuse me, to affiliations under data. And we are going to select MLeg sex off to mode. We're going to save it as MLeg sex off. One mode, and uh-oh, look what UCINet did. It remembered my last choice. I want to compare rows. I want to compare legislators. So I head back to rows. And I'm going to hit OK. And we have a whole lot of zeros. So many zeros that I'm going to see if there are any ones. Let's head back to the spreadsheet editor. MLeg sex off to mode ROAF. Did I not correctly label this? It's possible. Let's take a look at that. Okay, yes, it looks like we only have on the diagonal Gifford co-sponsoring with Gifford. That's understandable. Aha! Gifford co-sponsoring with Cray, Gifford co-sponsoring with Burns. We have a whole lot of zeros. Why is this? Because there are relatively few co-sponsors here. Aha! Gifford co-sponsoring with Sarti and with Kebra and McClellan. If I'm mispronouncing any of these names, please forgive me. And that's it for Gifford. Okay, only an occasional tie. Most people are not co-sponsoring these bills, and therefore the ties are few and far between pairs. Okay, that's interesting. I'm going to save this as MLeg sex off one mode to keep things parallel. Okay. And then I'm going to just go through the motion of running through a procedure, which is going to tell me something really interesting when we know how to interpret it. At the end of the semester, I'm going to ask you to collect similar information, either in an online network or in a political network. I want you to collect matrix information. Often it'll be two-mode, but you can collect some original one-mode data as well. And I want you, when you create these similar one-mode matrices that represent different ideas, similarity in gender, similarity in parties, similarity in committees, similarity in voting, maybe, or similarity in co-sponsorship, I want you to see if a set of those matrices predicts some kind of outcome that's measured in the same way. Here the outcome might be that co-sponsorship on sex offender legislation. We could ask a substantive question. Do people of the same party co-sponsor bills together? Do people of the same gender co-sponsor bills together? This is sex offender legislation. That might be a gendered issue. Do people of the same committees co-sponsor together unusually, disproportionately? To test this, we're going to end up going to, at the end of the semester, after we cover it in future weeks, tools, testing, hypotheses. From there, we're going to go to QAP, quadratic assignment procedure. And from there, we're going to go to MRQAP, linear regression. And today I'm going to select double-decker semi-partialing MRQAP, which is a detail that I'm not going to ask you to worry about right now. I'm going to select a dependent variable. A dependent variable is the thing I want to explain. That is going to be mleg, sex off, one mode. Overlap in co-sponsorship of sex offender legislation. This matters if you care about legislation about sex offenders. Who's acting politically together? Who's having political cohesion? This is no longer just a social network question. It is a substantive political question. And you can use social network analysis to answer that political question. One of the reasons why it matters. One of the reasons why having this skill may be important for you if you want to go into politics. Now I want to think about what a dependent variable is. It's an outcome that I want to predict. What are the things I think might predict it? Some independent variables. Oh, what ones are those? Maybe committee overlap. mleg committee, one mode. What else? mleg gender, one mode. What else? mleg party, one mode. Do people of the same party head in, and do they co-sponsor, sign on to support these sex offender legislative bills in the last session of the Maine State Legislature, having jurisdiction over the place where you live, work, go to school? Do these matter? Okay. It's going to create a random number seed. We'll talk about that later. It's going to have outputs on predicted values and model fit statistics and all that business. We're going to figure out what that means later on. Right now, I'm going to hit OK and show you that a result is possible. It's calculating coefficients. It's showing me right away that there's an R-squared of 0.004%. That means the independent variables explain just 0.4% of the variation in that dependent variable in the co-sponsorship pattern. It doesn't look like this is a model that works very well. Whoa, okay. And I'm going to have some p-values and some things like that that predict some stuff. Okay. We could talk about this in greater detail. As the weeks proceed, we will. Don't worry if in this last step you completely got lost. My job over the next few weeks is to get you to understanding what this table is, what it does, and what it means. But right now, I hope you feel a little bit more comfortable working with complete data covering hundreds of rows in many different columns to generate a series of matrices that are one mode, that are in the same form describing the same nodes, but having something different in the cells representing different ideas. If you can do that, you're most of the way toward running a meaningful social network analysis. And that's pretty good. until next week, this is James Cook from the University of Maine at Augusta. Have a good week.